Aluminum wire is indeed permitted for electrical power distribution in various types of buildings, including residences, churches, and schools. This is a common practice and is addressed in electrical codes like the National Electrical Code, or NEC. However, there are specific requirements and considerations that must be adhered to when using aluminum wire to ensure safety and compliance. Firstly, understanding the types of aluminum wire used in electrical systems is crucial. There are several alloys of aluminum, but the most common for building wiring is the Amanas 8000 series aluminum. This alloy is specifically designed for electrical applications and offers improved conductivity and mechanical properties compared to earlier aluminum alloys. Secondly, wire sizing and ampacity must be carefully considered. Aluminum wire has a higher resistance than copper wire of the same gauge, which means it will generate more heat for the same amount of current. Therefore, aluminum conductors must be sized larger than copper conductors to carry the same amperage. The NEC provides tables, such as Table 310.15b16, that specify the ampacity of aluminum conductors based on their size and insulation type. These tables must be consulted to ensure that the aluminum wire is properly sized for the intended load. Thirdly, proper termination techniques are essential to prevent problems with aluminum wiring. Aluminum is more prone to oxidation than copper, and this oxidation can create a high-resistance connection, leading to overheating and potentially fire. To prevent this, it is crucial to use connectors and devices that are specifically listed and labeled for use with aluminum conductors. These connectors typically have a corrosion-resistant coating and are designed to maintain a tight connection over time. The use of antioxidant compounds, also known as joint compounds, is also recommended when making connections with aluminum wire. These compounds help to prevent oxidation and improve the conductivity of the connection. Fourthly, compatibility with devices and equipment must be verified. Not all electrical devices and equipment are suitable for use with aluminum wire. Some devices may have terminals that are only listed for use with copper conductors. Using aluminum wire with such devices can create a hazardous situation. Therefore, it is essential to check the listing and labeling of all devices and equipment to ensure that they are compatible with aluminum wire. Devices that are listed for use with both copper and aluminum conductors are typically marked with the letter CO/ALR, which stands for copper/aluminum revised. Fifthly, proper installation practices are crucial for the safe and reliable operation of aluminum wiring systems. This includes ensuring that the wires are properly supported, protected from physical damage, and installed in accordance with the NEC and other applicable codes and standards. The NEC provides detailed requirements for the installation of aluminum wiring, including requirements for conduit, cable trays, and other wiring methods. Sixthly, inspections and testing are necessary to verify that the aluminum wiring system has been installed correctly and is functioning properly. A qualified electrical inspector should inspect the installation to ensure that it meets all applicable codes and standards. Testing, such as insulation resistance testing and continuity testing, can also be performed to identify any potential problems with the wiring system. Seventhly, addressing existing aluminum wiring installations is important. In some older homes and buildings, aluminum wiring was installed using earlier alloys and termination methods that are now considered to be less safe. If you have an existing aluminum wiring system, it is important to have it inspected by a qualified electrician to determine if any upgrades or repairs are necessary. Some common solutions for addressing existing aluminum wiring include replacing the aluminum wire with copper wire, installing approved splices between the aluminum wire and copper pigtails, and using CO/ALR rated devices. Eighthly, understanding the relevant sections of the NEC is vital. The NEC contains specific requirements for the installation of aluminum wiring in Chapter 3, Wiring Methods and Materials, and Chapter 4, Equipment for General Use. These sections cover topics such as conductor sizing, ampacity, termination methods, and device compatibility. It is essential to be familiar with these requirements to ensure that the aluminum wiring system is installed in accordance with the code. Ninthly, considering the long-term maintenance of aluminum wiring systems is a good practice. Aluminum wiring connections should be periodically inspected to ensure that they are still tight and free from corrosion. If any problems are found, they should be addressed promptly to prevent overheating and potential fire hazards. The frequency of inspections will depend on the age and condition of the wiring system, as well as the environmental conditions in the area. Tenthly, consulting with qualified professionals is highly recommended. Installing or maintaining aluminum wiring systems requires specialized knowledge and skills. It is always best to consult with a qualified electrician or electrical engineer to ensure that the work is done safely and correctly. These professionals can provide guidance on selecting the appropriate materials, sizing the conductors, making proper terminations, and complying with all applicable codes and standards. In summary, aluminum wire is permitted for electrical power distribution in residences, churches, and schools, but it is essential to follow all applicable codes and standards to ensure safety and compliance. This includes using the correct type of aluminum wire, sizing the conductors properly, using approved connectors and devices, following proper installation practices, and performing regular inspections and maintenance. By taking these precautions, you can ensure that your aluminum wiring system will provide safe and reliable electrical service for many years to come. Furthermore, consider the specific application when choosing between aluminum and copper wiring. For example, in large commercial buildings, aluminum conductors may be preferred for feeders and service entrance conductors due to their lower cost and lighter weight compared to copper. However, copper wiring may be preferred for branch circuits and smaller loads due to its high conductivity and ease of termination. The decision of whether to use aluminum or copper wiring should be based on a careful evaluation of the specific requirements of the project, including the load requirements, the available space, the budget, and the applicable codes and standards. Additionally, understand the importance of proper grounding when using aluminum wiring. Grounding is essential for protecting against electrical shock and preventing fires. Aluminum wiring systems must be properly grounded in accordance with the NEC requirement. This includes using grounding conductors of the correct size, making secure connections to the grounding electrode system, and ensuring that all metal enclosures and equipment are properly bonded. The grounding system should be inspected and tested regularly to ensure that it is functioning properly. Also, consider the potential for galvanic corrosion when using aluminum wiring in damp or corrosive environments. Galvanic corrosion can occur when two dissimilar metals are in contact with each other in the presence of an electrolyte, such as water or salt. Aluminum is more susceptible to galvanic corrosion than copper, so it is important to take precautions to prevent this from occurring. This can include using corrosion-resistant connectors and devices, applying a protective coating to the aluminum conductors, and ensuring that the wiring system is properly sealed to prevent moisture from entering. In addition, be aware of the potential for thermal expansion and contraction with aluminum wiring. Aluminum has a higher coefficient of thermal expansion than copper, which means that it will expand and contract more with changes in temperature. This could put stress on connections and lead to loosening over time. To prevent this, it is important to use connectors that are designed to accommodate thermal expansion and contraction, and to periodically inspect the connections to ensure that they are still tight. Moreover, it's crucial to use the correct tools when working with aluminum wiring. Using the wrong tools can damage the conductors or connectors, leading to poor connections and potential hazards. Always use tools that are specifically designed for use with aluminum wiring, such as crimping tools, wire strippers, and torque wrenches. These tools will help to ensure that the connections are made properly and that the conductors are not damaged. Furthermore, continuous education and training are vital for electricians and other professionals who work with aluminum wiring. Electrical codes and standards are constantly evolving, and it is important to stay up to date on the latest requirements. Continuing education courses and training programs can help professionals to improve their knowledge and skills and to ensure that they are installing and maintaining aluminum wiring systems safely and correctly. Furthermore, consider the environmental impact of using aluminum versus copper wiring. Aluminum is a more abundant and readily available metal than copper, and its production requires less energy. However, Aluminum mining and processing can have significant environmental impacts such as habitat destruction and water pollution. Copper mining and processing can also have environmental impacts such as air pollution and soil contamination. The decision of whether to use aluminum or copper wiring should take into account the environmental impacts of both materials. In addition, consider the life cycle cost of aluminum versus copper wiring. While aluminum wiring may be less expensive to install initially, it may require more maintenance and repairs over its lifetime. Copper wiring may be more expensive to install initially, but it may have a longer lifespan and require less maintenance. The decision of whether to use aluminum or copper wiring should take into account the life cycle cost of both materials, including the cost of installation, maintenance, repairs, and replacement. Moreover, it is always important to follow the manufacturer's instructions when installing and maintaining aluminum wiring systems. The manufacturer's instructions will provide specific guidance on the proper use of their products and will help to ensure that the wiring system is installed safely and correctly. Ignoring the manufacturer's instructions can void the warranty and can lead to potential hazards. Furthermore, keep detailed records of all aluminum wiring installations, including the date of installation, the type of wire used, the size of the conductors, the type of connectors and devices used, and the results of any inspections or tests. These records can be helpful for troubleshooting problems and for planning future maintenance and repairs. They can also be useful for documenting compliance with applicable codes and standards. Additionally, remember to always de-energize the circuit before working on any electrical wiring, including aluminum wiring. This is essential for preventing electrical shock and serious injury. Use a voltage tester to verify that the circuit is de-energized before beginning any work. Also, wear appropriate personal protective equipment such as gloves and safety glasses to protect yourself from hazards.